Let's talk about finding inverse functions. To find the inverse function, the inverse of a function, you switch x and y and you solve for y. The two basic steps. Switch x and y, then solve for y. To find the inverse of a relation, remember a relation is just a set of ordered pairs. All you have to do is switch the x and the y. So given this set of ordered pairs, the inverse of it would just be to switch each x and each y. So very basic, but I just wanted you to see an example of that in case it comes up in a question. A relation is considered a function when all the x values are unique. So remember, a relation is a set of ordered pairs, so it's anything we can graph. But it becomes a function when it passes the vertical line test, if you remember that, and if all x values are unique. So when we're finding inverse functions, sometimes something we're given is a function, and then we find the inverse of that function, and it may or may not be a function, but they like to ask us about that kind of thing. So I wanted to review, a function is when all your x's are unique, and sometimes after we find the inverse, that new function, the inverse function, is still a function on our graph, and sometimes it's not. But anyway, let's just look at some examples of finding it algebraically. So we're going to switch x and y and solve for y, and we'll look at the graphs in class together. So for number 1, you're given y equals 4x minus 2. It's linear, but the same rules apply no matter what function you're given. For inverses, we switch x and y, and we solve for y. So I'm going to just take x and y and they swap places. So x will equal 4y minus 2. That's my first step. Now I want to get y by itself. So let's add 2. And I get x plus 2 equals 4y. And divide both sides by 4. So x plus 2 over 4 equals the inverse of y. So to indicate the inverse of a function, you put a little -1. That's the notation for inverse. Y was equal to 4x minus 2. Now the inverse of it is x plus 2 over 4. Let's look at number 2. Given g of x equals x minus 2 cubed, we need to switch x and y. So in this case, g of x is like our y value. So we're going to put x over there, put y minus 2 cubed. So we need to get y by itself. We need to cube root both sides to get rid of the cube. So we end up with the cube root of x equals, and this cube and cube root would cancel out, so you have y minus 2, and you just needed to add 2 to both sides. So you have the cube root of x plus 2, but make sure not to write the 2 underneath the cube root symbol. And then that is our inverse of g of x. So right here, we can put it in proper notation again, because we had g of x, so we want to make sure we indicate that the inverse of g of x was what we have now. So it's just a little easier to work with y while you're solving it out. Let's look at number 3. Number 3, you're given f of x equals 3x squared minus 5. So it's quadratic, and f of x is like our y in this case. So we're going to rewrite it as x in place of y equals 3y in place of x squared minus 5. So we switched the x and the y. Everything else stayed in place. Now we need to get y by itself. So I'm going to add 5. I get x plus 5 equals 3y squared. So let's divide by 3. So x plus 5 divided by 3 equals y squared. So we need to get rid of the square. So we take the square root. So we would put, since we put the square root there, we need plus or minus the square root of x plus 5 over 3 is all underneath the square root symbol. And that is now the inverse of our original function, which was labeled f of x. So in the end of our problem, it'd be proper to put back the inverse of f of x is what we have found. Okay, so let's look at one more, and I think you'll have the idea just fine. Number 4 has y equals the square root of 2x plus 3. So it's a radical function. But notice no matter what they give you, you switch x and y, and then you get y by itself, and then just label that you have now found the inverse of your function. All right, so we're going to switch x and y. So x equals the square root of 2y plus 3. So we're going to get y by itself. We got to get rid of the square root. So let's square both sides. So we get x squared equals, and the square root will cancel out. So we get 2y plus 3. Now we need to subtract the 3. Still trying to get y by itself. So x squared minus 3 equals 2y. Continuing to solve for y, let's divide both sides by 2. And then we can we can write the proper notation. So x squared minus 3 divided by 2 would be equal to the inverse of y. So now, what I was mentioning on the first board is if you're asked if this is a function or not, you could now graph it and check your graph. So you could graph the original and see if it's a function, or you could graph the inverse and see if it is a function, or you could graph both and compare them. But on this video, we're just focused on how to find the inverse just using the algebra.